Hi everyone, Tina here, and today I'd like to talk about the 2 extra circle theorems you'll need to know if you're doing the Edexcel International Higher GCSE course. I have made another video which talks about the 9 circle theorems that are common to both the regular and international GCSE courses, so I'd recommend you have a look at that one if you haven't already. So let's have a look at the 2 extra circle theorems. They're called the intersecting chord properties. The first one is called internal intersection. So if that happens, then we say that AE times EB is equal to CE times ED. The second theorem is to do with external intersection. It says if 2 chords are extended and meet outside the circle, then we've got this rule. So this time AE times BE is equal to CE times DE. Okay, so now we've seen the 2 extra circle theorems, let's have a look at some examples which show us how to use them. Example 1. APB and CPD are chords of a circle. AP is 9 centimeters, PB is 6 centimeters, and CP is 8 centimeters. All of that information seems to be on the diagram, which is nice. We want to calculate the length of PD. So anytime there's an unknown that we want to calculate, my preference is always to kind of label that with a letter, for example, X. And now I can see what I'm looking for. This looks to be to do with internal intersection. So I'm going to write down the circle theorem that's to do with that we saw earlier on. Now this circle theorem tells us that CP times PD is equal to BP times PA. We know that CP is 8 and we know that PD is what we want to find, so X. We also know that BP is 6 and PA is 9. So now we have an equation that we can solve for X to get our answer. We can say 8X equals 54. Therefore, X equals 54 divided by 8, which if you do in a calculator, gives you 6.75. So that's the answer there, 6.75 centimeters. Example 2 looks a little bit more complicated, so let's have a look. So we've got A, B, and C, which are all points on a circle center O. OPC is a straight line. APB is a chord of the circle and bisects OC at the point P. Now, as soon as I read that bisects OC, I'm just going to make a little note on the diagram to remind myself that that means it's cut OC exactly in half, meaning these 2 lengths are going to be the same. Then I'm reading that AP is 7.2, which is on there, PB is 5.4, which is also on there, and OP equals PC. So that's reiterating the point that we saw earlier, that because it's being bisected, those 2 lengths are the same. Our goal is to work out the area of the circle, and we need to give our answer to 3 significant figures. In terms of a starting point, the goal, as we said, is to work out the area. Let's write down area of a circle equals pi r squared. Now, looking back at the diagram, the radius on this circle appears to be OC. If we label those 2 sections that are the same using a letter, let's say X, then that will be X and that will be X, meaning the radius is actually 2X. We can then extend OC across to the other side of the circle as the diameter and label that as 2x again because the radius is 2x. Now that we've extended it, it looks like the internal intersection circle theorem is at play again here, so we can use that to help us. Maybe if we label this one as point D, then DP times PC is equal to AP times PB. Everything is actually labelled on the diagram, so it's just a case of subbing the correct numbers and letters in here. So DP is going to be 3x according to our diagram, PC is going to be x, AP is 7.2 and PB is 5.4. Now we can tidy this up and do the calculation. So 3x times x gives 3x squared and 7.2 times 5.4 in the calculator is 38.88. We can then divide by 3, giving x squared equals 12.96. And then square rooting to get x. So x will be square root of 12.96, which works out to be 3.6. Now, if we go back to our original goal of finding the area of this circle, we said that area equals pi r squared, and we also said that the radius was equal to 2x. So let's write down what the radius is now. So 2 times 3.6, 7.2. Means we can just go ahead now and sub into the area formula to finish off the question. So area equals pi r squared, so pi times 7.2 squared, and that works out to be 162.86 something. We want to round to 3 significant figures, so that's approximately 163 centimeters squared. Last example. So we've got A, D, B, and E all being points on the circle centre O. A, F, B, C, O, E, C, and O, F, D are straight lines. Then we're told a bunch of measurements, including an unknown measurement CE, which is X there. And that's our goal this time, to work out the value of that X. Now, when I'm looking at this, I can see it's probably to do with the internal or external intersection theorems, but it would be really useful if we extended some of these chords inside the circle. So I'm just going to go ahead and do that so I can visualize what's going on a little bit better. So I've extended that one, and I'm going to give that point where it touches the circle a letter just so I can refer to it. So I think G is the next letter that hasn't been used yet, so I'll use G. And similarly, I'm going to extend the other chord as well from O going down that way. And next letter in the alphabet is H, so I'm going to use H. Next thing I'm going to do is use the internal intersection theorem to find this length, because we have enough information to do that. So let's go ahead and write down AF times FB equals GF times FD. Just filling in the numbers, so 7 times 4 equals that unknown length, so let's give it a letter, y, times 2. If we solve this for y, we get that y equals 14. Why is that helpful? Because now we can see that if y is 14, then the entire diameter of the circle must be 16. Because if you add that little 2 onto the y, that gives you the diameter. Now that we know that, we can use that in the other chord to help us. So when we extended from O down to H, that essentially is the radius. So if the diameter is 16, then that length is 8, and so is that one. And now we can use the external intersection theorem to help us find x. So that theorem says that HC times EC equals AC times BC. H to C is going to be the 8 plus the 8 plus the x, so 16 plus x. EC is just x. AC is 16 and BC is 5. So again, now we've used the theorem, it's just a case of solving this algebra. So let's go ahead and do that, expanding the bracket. So 16 times x, 16x, plus x times x squared, equals to 80. Rearranging this so that we get a nice quadratic equal to 0, looks like this. And then solving however you prefer. I think in this case, it's probably easiest and quickest to factorize into 2 brackets. X plus 20, x minus 4. And that's going to give us our 2 potential answers for x. So x either equals negative 20 or x equals 4 based on this. However, if we think about the context of this question, x cannot be negative 20 because it's a length. So we're going to reject that one and give our final answer as x equals 4. That's it for now. If you found this video useful, please do remember to like, comment and subscribe to my channel if you haven't already. And please do share this with anyone else that you think might find it helpful. Thanks and see you next time.